Here's a Speedster stabilizer rib, and these flanges are almost exactly 90 degrees, but not quite enough. All right, so what we're going to do is use these seaming pliers. Some people call them duck-billed pliers. We're going to grab the flange. Okay, we're going to have the pliers right into the corner there. Okay, all the way into the corner. We're going to grab the flange. Let me reposition this so we can see what we're doing here. And to bend this, we're not actually going to try and bend the flange, right? Because what that's going to do is it's going to put a curve right into this face, and we don't want that. We want it to be a nice hard bend. First off, I inspect my seaming pliers. I make sure that the edges don't have any real sharp corners or burrs, anything that could possibly crack the rib. Okay, so trying to do this single-handed here. Oh boy, you can see I've got one corner of the rib on the table. I've got the corner with the pliers on it off the table. All right, so now what I'm gonna do is push down. That's all you do, push down into the table. Okay, by doing so, what's going to happen is after you've worked this about twice, this flange is going to be perfectly 90 degrees, and that's where we want it. Okay, so that is how you take care of your stabilizer ribs. Very easy, no special tools required. One thing you do want to do is make sure that it's even and that you don't have any kinks in this rib. Okay, kinks will lead to a premature failure. So go ahead and do that to all your ribs. Once that's done, you can deburr your ribs on your deburring wheel or with your blue Rolock, and then they are ready for assembly on the stabilizer. The next step, of course, and I'm using my drawings here, is to start putting the ribs together from one end to the other. All right, so what we've got here is rib 1 through 7 down there. Okay, and here's a quick drawing. This is not what's supplied in the kit. This is just a quick shop drawing that we do here for our use. But you can see again rib 1 through 7, and this guy is a tube. It's not an actual stamped rib. All right, so your kit comes with a sheet full of these gussets. You cut them out, you deburr them, and you rivet them to the ribs with the blind rivets. It's a very fast process using blind rivets. So something to note are these two little gussets here. Okay, they look very similar, but they're not the same. We've got a slight angle change here. All right, and so the way to tell them apart is to get them oriented so the 3 rivet holes are, on the same plane with each other. In this case, on both gussets, those 3 rivet holes go that way. All right, so you can see that they're very different. So we'll put that guy there, this guy here, and I'll explain why they're different. All right, so right here on the trailing edge, you can see we have a straight line. Up here, it starts to kick up, well, forward. Okay, and that is why the difference in shape. Okay, so don't get those two mixed up. So what I want to do real quick is show you, for those who don't know, how fast it really is to do some blind rivets. Okay, we'll put this camera right here. All right, so we've got the gusset lined up. Again, these are all pre-drilled off of the router here at the shop. There's a couple different ways you could do this. You could put the rivet into the rivet puller and then down into the hole, or you could put the rivet in the hole first, which I like to do because it kind of keeps things positioned if I have multiple rivets in there. Slide this down onto the stem, pull the trigger. Now, this rivet puller and most are the same. It does have a container that goes on the back here that collects the rivet stems, but the problem with doing that is you have to tilt this back to get those rivet stems to fall into the container. Okay, so what we're going to do here is zoom out a little bit. Excuse the mess. We are a busy shop today. I am going to flip this over, and you can see we don't have, not yet anyway, we don't have any gussets on this other side here. So what I'm going to do is locate the equivalent part to the other side. In this case, we're using this guy here. I just put it on backwards. It goes up there like that. I'll go ahead and rivet all the gussets to this side now. Okay, and once that's done, what I can do is slide it over the tube, the spar tube, and this is what you'll get. Now, when you slide it over the spar tube, you got to make absolutely certain that you have your hinges in their appropriate rib bay. You don't have to actually position them yet, but in their appropriate rib bay before you rivet these in place. If you don't, you're going to be sad. Now, one thing I can say also at this point is when you put these ribs onto the spar, this is the tip here. Don't put your gussets on the tip. And that's because we have a weldment that slides in here. You need to drill the weldment to match the spar. Then the rivet goes through the gusset, the spar, and the weldment. Okay, so I'm going to go ahead and work on this guy here and continue to get it to the stage the other one is, and then we will get the tip weldments in, and those tip weldments are actually for the lead ballast. And then once that's done, we'll go ahead and start setting up the trailing edge, and this is how it looks from the factory. It's pre-curved. Once the trailing edge is in, we will go ahead and mate this elevator to the stabilizer. And the stabilizer, again, is pre-welded from the factory. It's a different type of assembly, really. So you don't need to worry about doing too much to that except for gluing on the ribs. And doing some, drilling of the bushings and stuff like that. But we'll get to that here in a little bit. Here I'm getting ready to set the hinges between the elevator and the stabilizer. Here's the stabilizer. Here's the elevator. You can see I've got an equal gap in between this hinge side and this hinge side, right? You see that in there? The idea being that if there's any misalignments after fabric covering, that little gap in there is going to help us take up that, we'll call it tightness, right? So what I've done is I have shimmed back here. This is 3/8 of an inch worth of shim material. Okay, I've shimmed this tube a 1/16. I've not shimmed this tube at all because that tube basically acts as the shim. And I've shimmed the leading edge a 1/4 inch. Okay, so what that's doing is it's putting the center line of every tube on this thing at the same height. Okay, so we're using this. This is 1 3/8 diameter. So the radius of that is 11/16. Okay, so to get the rest of this to 11/16, that's what it takes for shimming. All right, and I'm not so worried about shimming that I'm shimming within like a 32nd of an inch and checking everything. Okay, you can see what I've done is I've just put the blocks under there. I put some weight to hold things down. And what I'm going to do now, after I tap this guy back into place a little bit, I want to see a certain gap there. Oh. Okay, so this guy moves really easy. All right, so that's where I want him. This one's looking good. What I'll do now is go ahead and drill these holes. Okay, I'll move this out of the way, deburr the holes, put a little bit of primer there, slide this back to where it goes, and rivet it. Okay, now it's important to note that as you go, cleco each hole. That way, you have, there's 9 holes on each of these things, 3 on top, 3 on the back, and then 3 on the bottom. And you'll see this goopy stuff here. That is ECK. I think it's called ECK. It's an anti-seize lubricant. And basically what that means is if any moisture gets in between the steel part and the aluminum part, we're going to prime the aluminum again, but if any moisture gets there, that lubricant is going to help with keeping corrosion out of there. So to position this, one more thing besides just the shimming, and check your manual. Your drawings may be different by the time you receive them, but this is the center line of the airplane. This tube is offset that way by 1 inch, 1 3/4 inch, so 1.75 inches. Once we get all this dealt with, this sleeve will go here. We can't forget that sleeve will go on the outside of this tube to reinforce it. Once the hinges are set, what we're going to do is take a look at this weldment that we were talking about that comes in here. And that's what these holes will be for. So we'll go ahead and get these hinges set, we'll get them riveted, and we'll go from there. So I kind of shot myself in the foot here with the design of this. I like the design, right? But it does get tight right here getting that hole. All right, so what I might do for kit versions is add another row of rivets, so we'd have 4 total, but then move this off center up here a little more, so it's kind of on a 45-degree angle. That way you could get a little more of a straight shot into there with a drill, kind of like that, you know. So, but for now, if you don't have one of these, it's a handy little tool. It's a tight fit drill kit is what they call it. Now, if I had to buy this again, I would probably go for one with the all metal body, even if it took some hunting around, you know, the old style. Because this one, it didn't take long before I stripped the gears a little bit. It still works, but I have to apply pressure to the back of this thing while I drill. Otherwise it doesn't work. But I'll use this to get in there. And again, what I'll do for kits is move these a little bit further away. That way we have access to this, a little easier access. So now, worst case scenario, if I got this far, it would not be fun, but if I got this far and realized I couldn't get in there even with this, I'd have to drill out those gussets. But this is still the right order of priorities, right? That way we can make sure that this tube is clocked appropriately with the hinge and that tube and everything aft. So, well, you might be wondering, after I got that drilled, how I would actually get a rivet in there. Well, here is the secret. First off, I've got this rivet squeezer here. I like my other one better. My standard Home Depot rivet squeezer works a little better on my hands, but this one has an advantage that the head swivels. So you can see I've gotten it turned there, and that would still be too big to get in there, right? So what I did is I took this end here and ground a bevel on it. Okay, so what that allows us to do, again, I'm doing this one-handed here, so it's a little difficult, allows us to put that rivet in there like so, and then we're going to put a little bit of pressure on the table to bend that mandrel. Again, the mandrel is the little wire that comes out of the rivet. Now that that mandrel is bent, I can get this thing in there at an angle, and look at that, it actually fits. So see if I can squeeze this single-handedly. I doubt it. Hold on one sec here. I dropped my phone in the process, but now we've got that rivet in place. And then we'll go ahead and do the next two as well. And then this side will have to be done the same way. So that's how you get rivets into really tight spots. Any closer to this and I probably would have been in trouble, but the way it's set up right now, it works out pretty well. So all right, so here's that weldment we've been talking about. This is your balance tab weldment. Okay, so this part is going to go into the elevator spar. This part's going to carry a tube out, and this another tube out, and that tube is going to, as you can see, grab the trailing edge tube here. Okay, now You'll see that there's a diagonal in this weldment on this drawing that does not, it's not in the kits. It does not need to be there. What we're gonna do is slide this into the elevator spar. And I have everything shimmed off the table still. I haven't touched the shims. You can see that there's a popsicle stick there, some shims under there. These ones got moved a little bit, so I'll put them right back where they went. Okay, so we have a 1/2 inch gap here, all right? Now we use these little 1/2 inch tube shims for everything in the shop, for welding, for whatever we need. And then this is gonna be shimmed off the table 1/8 of an inch. Check your drawings to make sure that's accurate when you get your kits, because sometimes things change. So now, with everything pressed down tight to the table, I can drill these 4 holes, top and bottom. I can pull this back out, make sure all my deburring is done. I'm going to line the inside of this tube with some of this anti-seize lubricant, again, the same as we did here. And I'm going to rivet that in place when it's ready. Now, when it is ready, don't forget that there's a gusset that goes on top here as well. And that gusset is going to rivet to those 4 rivets or holes, and then it's going to carry this rib and also the number 7 rib, which goes here. So once the balance tab is in, then we can proceed to create these little tubes here that come out and grab the trailing edge bow. All right, so let's get this in, and then we'll move forward with the trailing edge bow. I've drilled the weldment, and as you can see, pulling it out kind of scars up the paint a little bit because of burrs getting stuck in between the tube and that tube. And then I deburred this with my Chaviv deburring tool, and again, just a refresher, the Chaviv deburring tool has this little hook on it. Maybe I can get a picture of it. There it is. And that hook allows you to get the inside of a hole, the burr around the hole. Now, because this is a steel weldment and this is aluminum, I want to make sure that I'm keeping my deburring hook right here for steel. I will use a different one for aluminum, and that's just because the steel tends to chew these up, and that can cause some big havoc on your aluminum when you go to deburr that. These can cause damage if used in the wrong way. And again, having this marred up from steel could cause damage on that tube. So I'm going to go ahead, and you can paint this if you want to. I don't think it's worth it, because then you got to sand it. And then when you sand it for the paint, then you're just taking off even more of the paint. So what I'm going to do is slather that ECK corrosion stuff on the outside of this tube. I'll put it on the inside of this tube. You know, a nice good coating, and then mate the two together, and they won't corrode if I do it that way. So right now this is pulled apart, it's upside down. I pulled it out of the jig for easier access to these holes here. So I'll go ahead and get this thing riveted in place. We'll set this back up on the table, then we'll worry about those tip bows, or the tip bow tips. You can see I've got one of these drilled out. That's because I made a classic Nick mistake, all right? So these are the BSPQ rivets. The problem with those is they have a steel mandrel retention that's supposed to be 100%, and in my experience it is. But I need to use this center punch to punch those mandrels down into the tube. And when I go to drill that out, it's that easy. Now I should have been using a drill stop. You can see I'm getting a little frazzled here. So what I'll do is drill those out, and then the gusset can go here, and that extra rib that I totally forgot to add. So we'll go ahead and get those in place. Here I've got my trailing edge bow in place. You can see it's long here, and I've trimmed this up here on the trailing edge just enough that it's not contacting the stabilizer, okay? Now, I've also marked and blocked a distance that's called out in the drawings from the end of the elevator spar, and in my case it's 56 and 15/16 of an inch from this outer edge to the end of the elevator spar right here. Now again, check your drawings. Your drawings may be different for whatever reason. What I'm noticing about this is that this is really sensitive to positional changes here and here, okay? Those two places. So one thing you got to make sure is that this is tight up against here. If it's not, you can see I'm rocking it. It's actually messing it up there, okay? So, but because this doesn't have any strength this way, this rib, I'm going to drill one of these first because it's triangulated. It can't really move. So I'll drill one of these and get a cleco in there, and then I'll move here, get a cleco in there. And then I'll worry about this stuff down here. And when I trim this, I'm going to trim it long, because what we'll do is after this whole thing is built, we'll come in with an angle grinder and very carefully take that down until it's where we want it. So you can see I've got my shims in here still, okay, underneath the trailing edge tube. I'm going to verify that I like where this is at. And again, making sure that this is pressed tight up against there. Looks good, looks good. I'll drill one of those. Here you can see I've got my tube this tube is supposed to go inside this tube. And I've marked a top dead center line on there so that I know the tube's not like that or like that, okay? I'm looking directly down over the stabilizers. I'm lining the two tubes up perfectly. You can see they're about perfectly lined up. And now I draw the rough entrance and departure angle in which the trailing edge tube will pass through this bigger 1-inch tube. Okay, so what we're going to do, let me get off the table here. What we're going to do is put this in a vise. Okay, we're going to drill an 1/8 inch hole on this side, as close to perpendicular to this top dead center as possible. And then we'll drill another 1/8 inch hole on this side. Okay, when we're satisfied that we have the location of that hole appropriate, we'll open up that hole to a 1/2 inch. Okay, and again, this is going to be kind of difficult because it's at an angle that we're drilling. So we're going to start with 1/8 inch or something small, 3/16, then we'll go to 1/4, then we'll go to 3/8, then we'll go to 1/2, because 1/2 is the diameter of this tube here. And when we're done, we'll have, you know, a hole that's angled through this tube. Now what we'll do after that is we will slot the end of this tube to where we can hammer it over this tube. So I'll show you how to do that here in just a bit. Alright, so I drilled an 1/8 inch hole from either side, okay, and then I drilled a 1/4 inch hole all the way through. So to get the first side started on the 1/4 inch, I had to go in kind of like this and then tilt it, and then very carefully, because this wobbles a lot when you're trying to do this, very carefully try and hit the other hole, the other side, from inside the tube, okay? Now what that does, as you can see, if I could get this right back on there, is this hole is nice and tight because it was the hole that, you know, it's an exit hole, but this side's wobbly, okay? So what we're going to do now is come back through with probably a 3/8 bit or a 5/16 back through the tight hole, exiting this hole here, okay? And again, we're just going to continue to step this up until it's at a 1/2 inch. Here's that 1/2 inch bit passed through the tube. Okay, you can see that we're all the way through. It was a little exciting, but nothing scary. And you can see that the trailing edge, I'm just verifying here, the trailing edge tube seems to be pretty well in line with that. So let's go ahead and notch this thing. And what we'll have is the ability to squish this tube down. We'll have 2 rivets top, 2 rivets bottom, and that's what's going to hold the trailing edge bow. So I've got this tube notched now, and you can see that I used the excess trailing edge material down here. I used the excess to verify that it does indeed go over the 1/2 inch tube. I don't want to do it up there because that's kind of on a curve, and this will give me a little bit more of an honest answer right here. So one thing I'm noticing is it's a little tight, and I'm marring up this tube, but it's gonna be cut off anyway. So what I'm going to do is I'm going to deburr the inside of this tube here around the notches. And what that's going to do is it's going to open that up just a little bit to where this is a nice fit. I got done smacking this thing around a little bit with a hammer. I put the tube in a vise. You can see it's marred up a little bit, but this tube is extremely thick for what we're using it for, okay? The reason we use it is because it's a cutoff from a different kit. So, I hammered that thing around the tube. That's what you get there. What I'll do is come in and clean up these edges, deburr it all, and then it will get 2 rivets, top and bottom, to hold it onto that tube up there. So it's a little bit of a loose fit, but that's not a problem because again, that's kind of a curve. It's not a straight line. So that loose fit may help us out there. We'll find out. I've got both of my tubes done here, my stabilizer tip tubes, and the drawings say that there should be a minimum 2.5 inch insertion into these tubes up here. Okay, so what I did, this tube was cut long. All right, I've done this whole thing with this tube extra long. Now I've marked 2.5 inches from the end of the tube, and when we slide this in there, we'll want to make sure that that line disappears. Okay, when that's done, there's a rivet pattern called for on the drawings. We will go ahead and drill for our rivet holes. Pull this back out, okay, and then trim. We'll find the last rivet hole, and we'll find 1/4 inch from the center of that rivet, and that's where the end of this tube will be. That way we could trim off the excess tube. We don't need that tube there, especially since we'll be packing this thing full of lead here in a little while at the end of this project. And I'd rather, you know, that space in here be taken up by lead instead of excess aluminum, right? So, yeah, so we'll go ahead and get that installed and fitting, and then I'll show you what the stabilizer tip looks like then. Well, that worked surprisingly well. You can see I got my tubes in here. Okay, I put these tubes, I removed the trailing edge. Okay, I removed this completely. All right, and then I installed these roughly where I thought they would go span wise. Right, it's pretty easy to tell because you've got this up here, and then you've got this block back here. Okay. Once that was done, again, the trailing edge was removed. Once that was done, I went ahead and slid the trailing edge up through this tube and into that tube, and went ahead and clecoed it back in place. Okay, and then I checked my shims. Everything's back in place. Now, because this guy tends to take a flare, see how the tube flares out because we hammered it down? It gets really tight in here to the point that it doesn't want to go in eventually. Okay, so what I did was I stuck this little 1/2 inch rod in there, or tube, heavy wall tube, and I rocked it back and forth and pushed until it slid in as far as it go. And when it got stuck, I put a C-clamp to compress the steel tube down to give it a flare as well. And when it was clamped, I went ahead and hammered some more, and it went in pretty well. Now I did lubricate it with that ECK anti-seize lubricant, so it did really help. It wasn't going to go in very well without that, but it helped a lot. So what I'll do now is there are, according to the drawings, 3 rivets on top and bottom here, and then 3 rivets top and bottom here, with 3 rivets on the back side, it looks like. Yeah, that's what it is. So I'll go ahead and install those, and then I can actually finish riveting up this assembly. The trailing edge tube is installed now. It's still long. I went ahead and put this inboard tube into place. Okay. The drawings call for 2 bolt holes. Okay, and they're going to be 1/4 inch when all is said and done. That means at the very end of the project, or the very end of mating this to the control horn. Okay, so right now, don't go past an 1/8 inch or number 30 on these holes. Leave them at that size. You'll also notice that they're top dead center to the tube. Okay. Now, these are the little gussets that hold this inside tube into place. Okay. What I did is I marked 13/16 of an inch from this edge to the bend line. And I put it in the brake, and you could do this by hand too with some seaming pliers. But I bent it to about 150 degrees. That's what it calls for in the plans. Every airplane is going to be a hair different. You could tweak these by hand again after you bend them. You could tweak them with the seaming pliers. So this gusset should be flush with this inside edge right here of the tube. All right. I shimmed this little guy off the table, in this case 3/8 of an inch, which is appropriate. I made sure that we had good alignment on this outer edge here, where the trailing, this inner, we'll call it the inboard tube, meets the gusset. And then I went ahead and marked with a Sharpie just 2 of these holes. And again, this is a number 40 bit, so it's undersized. I drilled these 2 holes, and then I clecoed the gusset to it. All right. And then looking down through, I went ahead and drilled these 3 holes and also these 3 holes. So the other side of this, you know, if this is the top or bottom of the stabilizer, the other side will be identical. Okay. And in addition to that, these holes are approximately 45 degrees, approximately, off of top dead center. So what we'll do is we'll have another set of holes on this side, 90 degrees to this set, and then same on the bottom. So what we'll end up with is 4 rows of 3 holes around this tube. And there are so many rivets there because it helps take the load from these bolts and kind of disperse it a little bit. Okay. These can either be the BSPQs as called out for in the plans, BSPQ 42 rivets, or you can use solid rivets. They're solid hard rivets. In this case, it'd be AN470 AD4- whatever length. So when this is done, it's also important to prime the inside, and you got to deburr this really well. Okay. I know we've been telling you to deburr things as you go, but this part takes a lot of loads from the control horn and puts them into the spar. So we want to make sure that these are all appropriately deburred. And optionally, and this is not something that's required, but optionally, if you wanted to use like a Scotch weld adhesive, like some of the airplane outlets sell, you could scuff this with, say, 180 grit sandpaper, scuff the inside of this with the same, and then Scotch weld it on the, you know, the 2 tubes together, basically glue the 2 tubes together while you're using your rivets. Okay, so that would be an incredibly stout assembly. The issue with using the Scotch weld in here is if something ever happens and you need to replace either this or the spar, you have to replace both of them. You can't do one or the other. So that's something to keep in mind. But if it ever comes to that, your life isn't exactly easy at that point anyway. You got a lot going on, so it may be a moot point. I got this all riveted up, and I did decide to use the Scotch weld adhesive inside the 2 tubes. Okay, now again, this is upside down so you can't see them, but we've got 2 bolt holes here drilled to 1/8 inch. Okay, those will eventually get opened up to 1/4 inch. But because there's a tube that slides in here still that accepts those bolt holes, we don't want any of that adhesive on the inside from here to the tip. Okay, it's okay to have a little bit of adhesive drips from this rivet back, or outboard I should say, but you don't want any adhesive inside the tube at the end. It's okay to have adhesive between the 2 tubes, right? Just not inside. So now what I'm going to do is, since I have some of that adhesive mixed up, I'm coming out here to our balance tab, And the kit comes with some plywood ribs. They go more or less like that, top or bottom. What you want to do is dry fit these to make sure that they clear the weld beads and stuff like that. And then scuff the tube with 220 grit sandpaper. 180 grit is also fine. You're going to take off some of that epoxy primer, okay? And that's fine too, because you're going to be putting the epoxy adhesive over that bare metal, okay? So just make sure it gets covered up. So once this is done, you're going to want to make sure that the tops are sanded smooth, that there aren't any glue boogers on there. And then when you go to cover this, we could put a piece of reinforcing tape or felt over those ribs. Now again, the ribs are on both sides, okay? And then when you get to the stabilizer up there, you'll be gluing the ribs on there also, and they're much larger ribs, but what they'll do is kind of coincide with this curvature here, going all the way forward so that you have a nice airflow. So we're going to go ahead and adhere these now, and then the only thing left is to trim that guy short, and then we'll take, not this hammer, but a rubber hammer, and very, very, very gently tap over the gussets. Probably not actually on the leading edge, but down here on the trailing edge, you can see we want to form that gusset to the trailing edge a little better, a little nicer. So we'll do that, and then this stabilizer, or sorry, this elevator is done. It's as simple as that. You can see I've got a little bit of a bead sticking out. I've got the clamps on it so it doesn't move. You could use tape if you had to. Clamps are better. It looks a little gloopy, but I made sure to smooth that out pretty good so when the fabric sits against there, it's nice and smooth. I also made sure that the wood came right to the end of that tube. Now if we needed to make any adjustments, let's say that we hooked this up to the stabilizer and found out that our gap here wasn't perfectly straight, we could always put a piece of balsa wood onto the face of that and sand it down at an angle to get that gap perfectly straight. So we're not going to know until we go to fit this again. I doubt that it's going to be a huge deal. Keep in mind also that this piece here gets a rib, and it can always offset that rib just a little bit to accommodate this. So we have different options there. If you were to put these ribs on after those ribs there, you could always, shift these ribs around to accommodate that. So there's multiple different ways you can go about that. All right, so we got two important things here. First off, when you press in these bronze bushings here, a gentle tap of the hammer does that trick. If that doesn't work, you can use a C-clamp and press it in, okay? That's the first thing. And then also don't forget to drill this to 3/8. Check your blueprints to make sure that that's still the accurate measurement, but this should be a 3/8 inch hole, and then you're going to want to deburr this after you drill it because it's going to get little burrs in there. This is the bolt that carries the bolt hole, the bolt bearing tube that carries the strut bolt. Okay, now backtracking to these bronze bushings again, if you get these in and the pin doesn't fit anymore, the 1/4 inch pin, that's pretty typical, and that's because this will compress that bronze bushing diameter just a little bit, okay? And also you might screw up the edge of the bronze bushing a little bit by tapping it in. If something like that happens, you can take a 1/4 inch drill bit and TIG weld it to the end of a long 3/16 inch rod, okay? And then this rod I just got from the hardware store, and then after you TIG it, you'll want to grind off the big weld bead. That way you can pass it through one bushing and into the next, okay? Now this is also handy in case we have some misalignment issues when we try to get the elevator pinned on. The way it's designed, you shouldn't have any misalignment issues, but what this might be able to do is clean up a burr just enough that you can get both those pins in. Now, your kit is supplied with ribs, higher quality than this, of course. This is just something that I had on hand and wanted to use for this specific airplane. But what we're going to do, this is Scotch weld. Okay, it's very much like JB weld, and for all I know, it's the same thing. What we're going to do is, I've got it in here in the Ziploc bag. I've got the corner cut off. We're just going to lay a quick bead. 1/8 inch thick or so is all it needs to be. These are for shape only, and they're non-structural. They are a required part of the airplane though, because they really help the dynamics of the stability. Okay, so you can see there I've got my 1/8 inch bead. The fat end, of course, goes to the back because that's the fat end of the stabilizer, and we're just going to set it right there like that. I like to do one side at a time through full cure, and here's why. Yes, we could do both sides and clamp it, right, the top and the bottom, but doing it this way, if I put the glue, the adhesive, on the rib and then set it back down, gravity helps, right? So we have plenty of adhesion there. So I like to do one side at a time. I'll come in tomorrow and do the other side, but for now this is what I'm doing here. And I can still do the other stabilizer. There's no reason I can't do 2 stabilizers at once, right? So I'm just squeezing the bag with my thumb. I'm not squeezing it with my whole hand. If I screw up and get a giant glob, I'm going to resist the urge to smooth that glob out with the bag. You want to keep the bag nice and clean. If you don't keep that bag clean, it's going to make things a mess everywhere. So I'm kind of rocking it back and forth, finding where it likes to sit. And that's that. So I'll do that to the whole stabilizer. When we get to this point here, excuse the mess, I'm a working man today, like I said. When I get to this point here, we're going to have that rib there, and then these ribs come shaped from the factory. They're half round, quarter round I should say. But the quarter round goes, man, I've got a mess going here. I better clean this up. Just too excited to build, I guess. So the quarter round goes like that, okay? And what that does is when you have your balance tab here, it kind of gives a rounded look leading into the balance tab, so it's kind of an even look. Now before covering, what we're going to do is put tapes on this, or felt. I haven't decided yet. Felt hides a lot of things, felt strips. You can also use felt to smooth out rivet heads. So I've got the ribs glued on now, and it might be a good time to point out I used the Scotch weld adhesive. Because these are non-structural, really, these are for shape. You just don't want them moving. You're probably okay using something like T88 epoxy or a good 30-minute epoxy from your hobby shop. Now, keep in mind, you do want it to be thoroughly glued. If you use, well, no matter what epoxy you use, you should be scuffing the paint with 220 grit sandpaper. But another thing that's an issue with these ribs is you'll see here that the rib kind of sits high to the tube, okay? So once this is all glued down, what you'll do is you'll come in, let's look over here real quick. You can come in with some sandpaper or like a Roloc disc, something like that, and kind of feather that in to where it meets the curvature just right, okay? You don't want it proud or anything like that. And it's pretty typical for these to be proud when you're done. The reason that these sit proud typically is because we route them a little bit tall at the ends so that they're not fragile, right? So go ahead and smooth those out with sandpaper, or like I said, a Roloc disc. I like the Roloc disc on a grinder just because it's a little easier to get really close to the steel tubes without hitting it. So yeah, so make sure you clean those up really well. Clean up And this one's still curing, so I haven't cleaned it up yet, but clean up the inside edge because you're going to see fabric touching that too. Now that the ribs are installed, the last step to getting this ready for covering is to install the gap seal, okay? So what we're going to do right now, I don't have this pinned here, I just have it free floating. All we're doing is, with this fiberglass piece, pushing it to the end of the steel tube on the horizontal, so the horizontal spar, okay? And we have these little templates, all right, and these are going to be in the manual, but you can kind of see the dimensions there, all right? Now, this gap seal has corners on it, all right? 1, 2, and 3. So that makes it easy to locate this height-wise, all right? So you can see that the top of the hole is going to be right on this corner, and the bottom is going to be right on this corner. First thing we want to do is with this to the end of the spar, okay, right here, and it's closed off, so make sure that you have that not overlapping the spar. You want it to the end but not overlapping the spar. First thing we do is mark the center of the hinge. You can see I've got it marked right there. All right, and I've marked this one as well. You can see that little line is the center. And I also marked, and I've already cut it, but I also marked where this hole is, okay? Now, once everything is marked, you put the template down here with the long side of the template facing outboard and this little notch facing up, okay? The reason it's like that is so that you don't see a whole lot of hole there from the top of the airplane, all right? So to get to the pins, you're gonna lift the elevator up and then you'll have access to this slot here. Now this is the same pattern as used on the vertical stabilizer, and you can offset the hole to either side. I prefer the left side of the airplane look the cleanest, but that's just my own preference. It could be on either side. Okay, so I marked out both of these, and I drilled this with a number 40 to start. You know, just I kind of eyeballed where that 1/8 inch radius would go. Then I opened it up to 3/16, and then I opened it up to 1/4 inch. Now we can clean all this up once we get this cut out. So the next thing we're going to do is cut out the slot with a Dremel tool, okay? Or if you had a way to get shears in there, like if you were to cut a big hole in the middle of this with a hole saw and then hand shear it, you could do that too. Speaking of hole saw, I used a 1-inch hole saw on this guy here, and again, that's for that there. The reason I made it so big was because we have to be able to get a socket in there, not to mention we have to be able to wrap the covering into there to make it nice and pretty. So yeah, and I also marked the end, okay? Now the end goes right to the end of that rib. There's no reason for it to go any further than that. One thing I would like to say about these fiberglass parts also is that any fiberglass part you get from Timber Tiger aircraft needs to be washed with water, okay? Because there's a mold release on here and probably remnants of wax. So wash them with water. We just hose them off, that's all. But you want to wash it with water before you mark this, because if you mark this, that mold release, if there's any left, might start flaking off and it'll take your markings with it. So once we get these holes cut out, we're going to set this onto the horizontal stabilizer side, and then we will pin the elevator to the horizontal stabilizer. And the reason we want to do that is because then we could set our gap to 3/16 of an inch between the two, between the gap seal and this elevator spar. And 3/16 of an inch is a good starting point, because once you get fabric on everything, it's going to tighten up closer to 1/8 of an inch of a gap, and that is really ideal. That's about as tight as it really needs to be. And then after we get this setting on there, what we'll do is we'll tape a straight line, and this is again another reason you want to wash this off and get that mold release off of there. But we'll tape a straight line on this edge. You can see the edge isn't straight right now, it's very wavy, and then we'll trim that edge nice and flat. Once that's done, we will adhere this to this spar while everything is pinned together, and we'll leave it until it's secured up. Then we'll pull the pins out of the bottom, and we'll be ready for covering. So last note before I move on to getting this done is you need to make sure, please make sure, that you make lefts and rights, okay? My employees get tired of hearing this, I'm sure. I say equal lefts and rights all the time. Alright, so this is the left stabilizer. I know that because the little slot's facing up and outboard is that way. So on the next one, we want to make sure that it's done backwards. Okay, because if you don't, what you'll have is you'll see this slot on the top of one stabilizer, but you won't see it on the top of the other one. So you'll have some asymmetry if you do it wrong. If you do screw it up, go ahead and just fill that back in with fiberglass cloth, or you can call us and we'll send you a new one. These are the most difficult pieces that we have to fiberglass just because the mold is so tight. So they're not very inexpensive to make. So try really hard to get it right the first time. Equal lefts and rights, always. Speaking of which, you can see I've already mated my horizontal with the elevator. This is set A, and then I do have a set B. And I'll write A and B on these as well if I need to, just to keep everything straight. So, equal lefts and rights. Alright, so yesterday, just before I quit, I went ahead and installed these. I used the Scotch weld adhesive, and the reason I used that is because as gloopy as this looks, it's actually very smooth. The adhesive smooths out really well. So it means a lot less cleanup work. What I'm going to do is I'm going to take a blue Rolock to very gently clean this up. And it doesn't have to be perfect because I'm going to put some felt over this prior to covering, okay? And the felt is going to smooth everything out. I'm also going to make sure that my ribs are all sanded down nice and smooth for a smooth transition into that gap seal. One thing I did do when I was installing the gap seal is I've got pins in here, okay? I've got this taped so that way, you know, it helps keep the elevator from moving in relation to the horizontal stabilizer. And I also use these shims, which every popsicle stick's a little different, but that's about 3/16 of an inch. And I taped on the gap seal, okay? So to glue this down, all I did was I put a little bit of adhesive into a Ziploc bag. I cut the corner off. I put a really tiny bead on the tube, slid the gap seal up onto that bead, and you can see through the fabric, okay? I mean through the fiberglass. So you can see if you've got good adhesion. Once that was done, I took another really small bead right on the edge, okay? And I smoothed that out with my finger. Now it's a little bit of flip it over, a little bit of back and forth between top and bottom, because you want to kind of walk the gap seal until that center point there is, you know, centered with the radius of the tube. So next thing I'll do is go ahead and remove any Sharpie with some lacquer thinner, and I'll also make sure that any PVA, any of that mold release is off of this. So I might wash it one more time with water, just the gap seal. Now one other thing I messed up was, you can see right there, I somehow got my trimming length off by about 1/8 of an inch, a little less. So what I'll do is I'll fill that up with a bit of wood, bit of balsa wood maybe, and sand this interface flush, and it should be at that point everything ready for fabric. So not much left to do. So here you'll see that I am covering the first elevator. I'm using AirTech coatings. That's the system that I prefer. Now, I'm not going to show you how to cover this completely, okay? Because that is something that you should lean on the system's manufacturer to instruct you on, whether it's AirTech coatings or Stewart systems, whatever system you're using, okay? But what I can say is I want to show you some things that are specific to the Speedster. All right. First off, we have a rib here in the balance tab. There's no reason to rib stitch that. All right, you can if you want to, but there's no reason to. These ribs, the ones that go perfectly longitudinal, those ones get rib stitched. And you can rib stitch the diagonals, but you don't need to. Okay. Now, as you know, you have to have 2 layers of fabric wherever there's a contact point, which is why I'm going to put a fabric tape here. Now, because the ribs aren't perfectly 90 degrees and because the fabric isn't always going to be perfectly 90 degrees to the face of the rib, we may only have one contact point, okay? And that's going to look kind of weird if you have, perfect 2-inch tape here and the contact point is only off to one side, all right? It's going to look a little bizarre. So what I did is I put a reinforcing tape down the center of that. That way, when I iron this down, whether there's one contact point or 2, it always looks like there's 2 contact points. So that's why I did that, okay? Now what I have to decide is if I am going to start a pattern of tape, 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 outboard or inboard to outboard or outboard to inboard. But what I'm thinking I want to do is do my diagonals first, and then I'll have my ribs on top of those. That way here at the base, we'll have the diagonals coming all the way into, well, what I'll probably actually do is cut the diagonals so they meet each other right here at the center of the rib. And then I'll put the rib tape over the top of that to clean it up. Okay, so once all the tapes are done, as you know, once all the rib tapes are done, then you do your perimeter tapes, and it kind of cleans up this goobery looking stuff here. Alright, so what I'll do is I will get these tapes on and move forward with covering. Again, you're going to want to lean on the system manufacturer for instructions. So I'm probably not going to make any more videos on how to cover this elevator. Okay, there's really no reason to.